Okay, so on Wednesday we learned how to go from a formula to a percent. And every time I had the same formula, I'd get the same percent. So today we're going to take that percent and turn it back into a formula. Okay, so we're going to go from percentages to formulas. Now, we're not going to be able to get the exact chemical formula. What we're going to get is something called the empirical formula. Empirical means from lab data. Empirical evidence means you went out and weighed stuff. Okay? Empirical means they got it from lab data. So what formula can we get from lab data? What we can get from lab data is the lowest whole number ratio of elements in a compound. I wish I had gotten your homework graded because the last two on the percent composition one, they were the same. The reason why they were the same was because the ratio was the same. It was C4H8 and C2H4. There was always four. So C2H8 and C2H4 had the same percentage. The reason why they had the same percentage is because they had the same ratio of carbon to hydrogen. Because C2H8 is 2 hydrogens for every carbon, and C2H4, come on, it's a pen, right? C2H4 and C4H8 are both 1 carbon and 2 hydrogens. So since their lowest ratio is the same, their percentages are going to be the same. So percentage will only tell me the lowest ratio. It wouldn't let me differentiate between C2H4 and C4H8. There is a way, but I can't do it with just percentages. I'll need more data. So CH2 is an empirical formula, and I'm sure it's an empirical formula. Is it a molecular formula? Well, the question is there really something out there that's CH2? You can't be sure. Okay? Does that make sense? You're sure it's empirical. You don't know if it's molecular. It might be. C2H4, you're sure is molecular, and you know it's not empirical because it's not the lowest ratio. C3H6. We know for sure that's a molecular formula. We know for sure it's not an empirical formula. So the first one I'm sure was empirical, didn't know if it was molecular. The next two I can tell for sure were molecular and not empirical. H2O is both. How do I know it's the empirical? Well, because I can't get lower than a 2-to-1 ratio. How do I know it's molecular? Because water is really H2O. So the only way you know it's really molecular is you really know the formula of that chemical. It's something you have to know in advance. Otherwise, you need some more information. Make sense? Okay. So to find the empirical formula, sometimes it's easy. If they give you a formula, you just have to find the lowest whole number ratio. So, for example, is C6H12O6 an empirical formula? No. What would its empirical formula be? Look for the common factor. All of those have 6's in common, right? So I divide everything by 6 and I get CH2O. So glucose has an empirical formula of CH2O. In fact, there's an entire family of chemicals that have that empirical formula. Okay? And it looks like they put water together with carbon. that they took carbon and hydrated it, made it a carbohydrate. All carbohydrates have this empirical formula. That's why they're called carbohydrates. Okay? So when you talked about sugar, it's C11, H22, O11, CH2O. Okay? So that's why they're called carbohydrates. Okay, what is the empirical formula CH4N2? So the correct answer is CH4N2. Because there's only one carbon. I can't divide it by anything. They don't have any number in common. So CH4N2 is both a molecular and an empirical formula. Now, so this is a ratio of atoms, right? So that's what I want to get to. I want this many atoms over that many atoms. I want to get to a ratio. But we can't count atoms. But if it's a ratio true in atoms, it's also going to be true in a ratio of moles. So the ratio that's in atoms is going to be the same as the one that's in moles. So if I want to turn a percentage into a formula, I have to turn percent into moles. Because once I turn percent into moles, then I'll be able to take a ratio. Then it should be a whole number ratio. Because it's got to be a whole number of atoms. Does that make sense? So, how are we going to get there? The secret is to make the math easy on yourself. Assume you have 100 grams. Why does that make the math easier? If something is 70% carbon and you have 100 grams, you have 70 grams of carbon. I picked 100 because it makes the math easy. I could have picked any number of grams. I could have picked 7 grams. If it's 7 grams, well, 70% is still, right? 70% is still carbon. That means it's 4.9 grams. I could pick any number. I picked 100 because it makes the math easy. I can do it in my head. So I can pick any amount because the percentage is going to stay the same no matter what amount I have. I'm going to pick 100 because it makes my life easy. Because then the percentage become grams. Grams I can turn to moles. So I can find the moles of every chemical. And my goal is to get moles over moles. And you're going to find the whole number ratio easiest if you find the smallest number of moles and divide that into all the other ones. Divide everything else by the smallest number of moles. Now, notice this doesn't say it had to be a whole number. It had to be a whole number ratio. So if you get 2, that's a whole number. What if you get 1.5? Is 1.5 a whole number ratio? 1.5 is 1.5. 1.5 is 3 halves. 3 halves is 3 over 2. It is a whole number ratio. That's what we mean by whole number ratio. 1.5 is 3.5, that's 3 over 2. So you're going to have to think about your fractions, your decimal points as fractions. And the ones I expect you to be able to find are things like 0.25. 0.25 is a quarter, right? 0.33. So 1.25 is a quarter, so 4.25 would be 4 1/4, which would be 17/4. Backwards of what you're used to doing, right? So 0.33 is a third, so 1.33 would be 4/3. 0.5 is halves. 0.67 is 2/3. 0.75 is 3/4. We're okay with those decimal equivalents of fractions? Okay, those are the kinds of things we're going to have you look at. You might have to look at 0.2s as 1/5. That's about as far as you're going to go. That make sense? Okay, so let's try one. Compound is 38.67% carbon, 16.22% hydrogen, and 45.11% nitrogen. See how this is just backwards of the kinds of things you wrote as your answers to percent composition problems. So I'm giving you the percent to start with. We got to turn it into a formula at the end. So it's moving exactly backwards. They push it forward. Okay, no problem. I got it. No problem. I can do that. No, I got it. Everybody else passed it backwards, like I asked. Okay. So where do I start? Well, I can pick any amount, and those percentages will be the same. So I'm going to pick 100 grams. Because then I can say, if I got 100 grams, 38.67 grams of them are carbon. Carbon's 12.01 grams for 1 mole off the periodic table. So I got 3.220 moles of carbon. Then I got to do hydrogen. 16.22 grams of hydrogen. 1.1 mole is 1.01 gram, because hydrogen's not by itself. It's in the middle of a chemical here. That's why I'm not doing H2. It's not H2 here because it's part of a chemical. It's not alone. That gets me 16.1. There's only 3 sig figs in 1.01, so I can only have 3 sig figs in my answer. And you should guess what the next line is going to say. The only thing is you may not have memorized nitrogen yet. You'll get there. Okay. 45.11 grams of N, 14.01 grams for 1 mole of N. That means I got 3.220 moles of N. So it's not new math. This part is just figure out how many moles you got. Assume 100 grams, figure out how many moles. That's doable. Okay. Then you want to take ratios. Which of my numbers was the smallest? Yeah, carbon and nitrogen were both 3.220. It doesn't matter which one I pick. I picked the nitrogen. So I'm going to divide everything by the nitrogen. So 3.220 moles of carbon divided by 3.220 moles of nitrogen means I have 1 mole of carbon for every mole of nitrogen. Which means my coefficient next to carbon is 1. And my subscript next to carbon is 1. My subscript next to nitrogen is 1. I divide 16.1 by 3.220. I get 5 to 1. So I got 5 moles of H for every mole of N, which means I have 5 atoms of H for every atom of N, and every atom of carbon. So my formula is C1, H5, N1. We tend to put it CHNO. Okay? I tend to do it in the order they give it in the book, but the order tends to be CHNO. Yeah. You don't have to put the ones. No, I put them there explicitly so that you knew where I got them from. So the real answer is going to be CH5N. But you see why I wanted to be explicit on this one. Okay. So, tedious, with a little bit of thinking at the end. Pick the smallest one, divide it in two. So you got to be wide awake when you do these problems. So, what's the empirical formula of caffeine? Okay. Brighten this up. Should be light there. All right. So, I've got, see how my hand works, 49.48% carbon. So that's 49.48 grams of carbon, 5.15 grams of hydrogen, 28.87 grams of nitrogen, and 16.49 grams of oxygen. Oops, it's upside down. Guess that doesn't work very well, does it? Gonna have to do it on the board because it won't flip for me. Unless I do. Nope, that doesn't work. Bizarre. Okay, well, I have to do it some other place. I tried. Okay, so don't have enough board. So 49.48% carbon, so that's 49.48 grams of carbon. Change grams of carbon to moles of carbon. 1 mole is 12.01 grams. 5.15 grams of hydrogen. Grams of hydrogen to moles of hydrogen. 1 mole is 1.01 grams. 28.87 grams of nitrogen. Grams of nitrogen to moles of nitrogen. 1 mole is 14.01 grams. And 16.49 grams of oxygen. 1 mole of oxygen weighs 16.00 grams. So we do some divisions. 16.49 divided by 16 is 1.031 moles of O. 28.87 divided by 14.01 is going to be pretty close to 2. It's 2.061 moles of N. 5.15 divided by 1.01 is 5.10 moles H, and 49.48 divided by 12.01 is 4.120 moles of C. Hey, which one of those is smallest? Which one's smallest? The oxygen, right? So I'm going to divide all the other ones by the oxygen. So I got 4.120 moles of carbon divided by 1.031 moles of oxygen. If you push that on your calculator, it's going to come out really close to 4. You get 3.996. And we're looking for a whole number ratio. So what whole number ratio is that going to be? That's going to be 4. So that means there's 4 moles of carbon for every 1 mole of oxygen. My 5.10 moles of hydrogen divided by 1.03 moles of O. 5.1 divided by 1.03 is, it's 4.95. Whole number ratio we're thinking there, is that close to any other fraction that we know of? I mean, it's 19/20ths, but we're probably not going to have 19 and 20, are we? No, so this is probably 5 moles of H for 1 mole of O. And then 2.061 moles of N for every 1.031 moles of O. Hopefully you can see that this is going to come out to be pretty close to 2, because twice this is 2.062. So it's going to be 2 moles of N for every mole of O. So now I've got my answers. The number next to carbon is going to be a 4. The number next to hydrogen is going to be a 5. The number next to nitrogen is going to be a 2. And the number next to oxygen is going to be a 1. And that's the empirical formula of caffeine. Tedious, right? But not real hard. And we're doing it, I mean, it is backwards. We do every step just about backwards. Okay? Last one, actually, I did the math because I did it in my head. 2.061 divided by 1.031. Rounding stuff, yeah. Yeah. Now, these didn't come up with any fractions, so I do want to give you an example of one that comes up with fractions, what you do there. Okay? So I think this is one. If I remember correctly. Oh, I'm sure I remember correctly now. Yeah, it's got to be the right one. Where do I begin? I start off by copying down what they gave me. .9%. Well, that's not going to be a percent. That's going to be a grams. And 47.1 grams of O. 26.98 grams of aluminum is 1 mole of aluminum. 16.00 grams of oxygen is 1 mole of oxygen. 52.9 divided by 26.98 is 1.961, or 1.96 moles of aluminum. only 3 sig figs. 47.1 divided by 16. 2.94 moles of O. $47.1 divided by, oh sorry, which one? Which one of those is smaller? 1.96, right? So 2.94 moles of O over 1.96 moles of Al. .94 divided by 1.96 equals 1.5. It's supposed to be a whole number ratio. Do I round it up to 2? Do I drop the 1 off and make it a 1? Neither one of those are reasonable choices, are they? It's 1.5. 1 1/2, which is 3/2. Turn it into an improper fraction, because that improper fraction is your ratio. The reason why you want to put the small one on the bottom is because very few people know what fraction is 5/3 or 3/5. Because if you do it the other way, you're all going to get decimal points. You're going to have to turn that decimal point into a fraction. It's easier if you put the big one on top, because you'll get an improper fraction and you'll be able to see the decimal point a little bit better. Oh, just divide them all by the smallest, and if you have to double one, you have to double everything to keep the ratio the same. So this is going to be Al2O3, okay, which shouldn't surprise you. Al's 3 plus, O's 2 minus. Crisscross. You'll get Al2O3. Right? So everything we've written for ionic compounds has always been an empirical formula. We always did the lowest ratio. So what Chubby was answering was, what if there was a third one besides that oxygen? What if there had been a hydrogen, right? And we found out that the hydrogen, the moles of hydrogen to the moles of oxygen was 1 to 1. Or moles was 2 to 1, right? So when if I tried to fill that in, I'd go AlOH. By the way, I'm just making up stuff now. Oh, what the heck? It moved on me. AlOH, right? And the number I'd put next to Al would still be the 2. The number next to O would still be the 3. But notice down here I got 2 moles of O. So if I have 1 mole of O, I'm going to have 2 moles of H. So if I have 2 moles of O, I'd have to have 4 moles of H. So I'd put a 4 there. Does that make sense? So if one of them has to be doubled, they all have to be doubled. Otherwise, your ratios aren't whole number ratios anymore. You put some fractions in the middle of them. Does that make sense? So that's all there is to it. The homework, it is the right pages, 231, 123, 233, 123, and then 35 and 36. So, and here, and if it'll let me drag it up like it's supposed to. Okay. So there is the first 1, 2, and 3, and you will notice that right next to it, it has the answers. I'll be looking to see if you can do the work to get that. Does that make sense? Okay, so you got 8 of these to do. Here's one of them. Probably get knocked off a little bit along the way. Make sense? There we go.